Hey everyone, welcome to the third video in our series on the atomic model. And today we're going to be going over J.J. Thomson's model of the atom known as the Plum pudding model. Now, this was actually an improvement from Dalton's atomic model, which said that, as to review, that atoms were just nice big solid spheres that didn't really have any other interesting properties. They just formed compounds and fixed whole number ratios. And every piece of matter was made out of these atoms. Now, J.J. Thomson actually conducted an experiment almost 90 years later. In a cathode ray tube, he shot a beam. Okay, and then he put a magnet around that cathode ray tube. So let's take a look at what his experiment looked like. Oh, let me just draw it right here. So he had a cathode ray tube, which looks something like this. So it's just a tube. And there's a cathode ray. My artistic skills are not the best, but I can try to draw this cathode ray. So he just shot a cathode beam right here to the tube. Now what happened is that he took a magnet and put it around the tube. So let's say he put a magnet here, and what ended up happening is that the electrons, or we didn't know there were electrons at the time, but the stuff in this beam got deflected. So I'm gonna do that. So the stuff in this beam got deflected. So the beam actually looked more like this. Looked more like that. And when he saw this, he was very shocked. He said, how can this beam get deflected so much? Originally, it was just straight like this. Now it got moved all the way up here. He hypothesized this would only be possible if there was some negatively charged particles in the beam that would get attracted to this magnet and get deflected. Now, he decided to give these negatively charged particles a name, the electrons. Today we know electrons are much more than just negatively charged particles. They're actually the fundamental guiding force behind everything that happens in chemistry and thus everything that happens in today's world. But, of course, J.J. Thomson must not have known that yet at the time. So he proposed a relatively humble yet and simple plum pudding model, which takes this idea of negatively charged electrons and incorporates them with a positive charge to neutralize an atom. Because at the time, we knew that atoms did not exist always charged. They needed to be neutral. So he incorporated these electrons like plums into a pudding of positive charge. So we can see that here. We have this pudding of positive charge. There's no specific positive charge center. It's just a big entity of positive charge. And within this entity of positive charge, there are scattered little electrons with negative charge. And the atom is held together by the attraction between the positive pudding and the negatively charged plums. And these negative charges, this model supported his experiment because then he knew that this beam was getting deflected due to these negatively charged particles. So this was the model that J.J. Thomson came up with. Of course, at this point, we would think it's a little bit silly to put an atom like plum pudding, especially given what we know about the current model of the atom. But remember, given the information they had back then, this was relatively impressive, the amount of information they were able to pull from this. And I believe J.J. Thomson actually earned the Nobel Prize for this discovery, his plum pudding model. Then later on, we would have even more scientists come and improve on his model. So in the next video, we're going to talk about how Ernest Rutherford took this even a step further to develop the plum pudding model into something that would more resemble today's model of the atom by discovering the nucleus.